In this video, we're going to learn the three methods of finding the GCF of a given set of numbers. But first, let us review the basic definition of GCF. So what is GCF? GCF is the largest number that divides evenly into its number in a given set of numbers. Or, that is the greatest factor that divides two or more numbers exactly. For example, you are given with a set of numbers here, 12, 13, and 42, and we are required to find the GCF. And the GCF of this three number happens to be 6. Since when we divide this three number, it will give us a number which is exact. So let's try. So 12 divided by 6, so the answer is exactly 2. 30 divided by 6, it happens to be 5. 42 divided by 6, that is exactly 7. Now, GCF can also be known as the highest common factor, or shall we say HCF or GCD, the greatest common divisor. Now, why do we need GCF? May pagkakataon ba na we will need the GCF? Yes, when we perform fraction. We may need to add subtract fraction 5 all over 6 plus 3 all over 9, wherein the answer is equal to 21 all over 18. If we want to simplify 21 all over 18 in the simplest form, we need to find the GCF of this fraction. So the GCF of the fraction 21 all over 8 is simply 3. So when we divide 21 by 3 and 18 by 3, the answer should be 7 all over 6. We can also use it for simplifying ratio to determine the GCF. For example, so we have the ratio 3:6. That can also be written as 1:2. Since the GCF of 3:6 is simply 3. Since 3 divided by 3, and that's understood to be 1, and 6 divided by 3, that is simply 2. Now, how do we find GCF? GCF can be found when we list out the factor of each number, and then we need to find the greatest one that is common between the given in between the two. But we need to study the three methods kung paano kinukuha ang GCF. So the first method is simply the Prime Factorization Method, and the second method is the continuous division, and the third one is the listing method. So let us solve a few problems that will help us to make sense of how the GCF works. For our first problem, let us find the GCF of two numbers 32 and 48. First, we do the prime factorization of each number. So step 1, factor each number into primes. So we have the given number 32. Now, if the given number is simply an even number, just simply divide it by 2. So we divide it by 2. So the answer is 16. Since 16 is an even, so continue dividing it by 2. So we have 2. So 16 divided by 2, so that is 8. Then 8 is an even number again. So 8 divided by 2, so that is equal to 4. 4 is an even number, so divided again by prime number 2. So the resulting value should be 2 also. And then the next step, encircle all the prime. Since prime 2 is a prime number, then we will list all the factors of the given number 32. So we have 32. So we have the 5 2 prime numbers. And then for the second number, we have 48. Again, 48 is an even number. So this time we divide this again by 2. So the resulting answer is 24. 24 is an even number. Divide again by prime number 2. So the answer is 12. 12 divided by 2. So the answer is 6. 6 is also a prime number, so continue dividing it by the prime number 2, and the answer is simply 3. And the next, encircle all the prime numbers, so we have this, and then list all the factors of 48. 48 is equal to 4 2 prime numbers 2, and we have the 3 prime number. And then the next step, we need to find the GCF. So the GCF is simply the product of this encircle common factor that's shared by the given number. So we have the first common factor that's shared by the two numbers. So we list down the 2 here. And then we have the second common factor shared by the given two numbers. So we have times 2. And then we have 2 again. And the last common factor that are shared by the given number is simply 2. Then to find the GCF, we will multiply these factors to obtain GCF. And it happens to be 2 times 2 times 2, so that is simply 16. Next step we have is the continuous division method. So we have the same problem, 32 and 48. So the first step is we're going to divide each number into its prime. So again, we have the given number 32. 32 is an even number, so that is divisible by 2. So we find the quotient, 32 by 2, so that is 16. Then 16 can also be divided by a prime number 2. Then 16 by 2, the quotient is simply 8. Then 8 can be divided by 2, the answer is 4. And 4 can be divided by 2, and the answer is simply 2. Then 2 can also be divided by a prime number 2, and the quotient would be 1. That is for the 32. And then for 48, so 48 is an even number, so divide the first prime number, which is 2. So 48 divided by 2, so that is 24. 24 divided by 2, so that is exactly 12. 12 divided by 2, and that is simply 6. 6 divided by 2, so that is 3. Now 3 can be divided by the next prime number, which is 3. So 3 divided by 3, understood to be 1. Now if the quotient is simply 1, then we stop. Next, how do we find the GCF? So to find the GCF, we will list all factors, then circle the common factor that are shared by the given number. So we have the first factor that's shared by the given two numbers. So that is simply 2. So copy 2 here. And another common factor that's shared by two numbers. So we multiply it again by 2. And the next 3 common factor. So we have 2. And the last we have the last common factor that's shared by two numbers, that is simply 2. And then to find the GCF, we will multiply the factors. So 2 times 2 times 2 times 2. So the GCF of these two numbers is simply 16. Okay, another method in finding the GCF of these given two numbers is simply this one. So we have 32 and 48. So these are even numbers, so divided by 2. So the resulting quotient would be 16. 48 divided by 2, so that is 24. And again, 16 and 24 are even number, so we can divide it again by 2. So 16 by 2, that happens to be 8. 24 divided by 2, so that is 12. 8 and 12 are even numbers, so we can divide it again by 2. So 8 divided by 2, so that is 4. 12 divided by 2, so that is simply 6. 4 can also be divided by 2 again. So we divide by 4 by 2. 4 divided by 2, so that is 2. 6 divided by 2, that is simply 3. Now, stop na tayo dito since we have the common factor 2, 2, 2. Then to find the GCF, encircle this prime divisor, and that it happens to be 2 multiplied by 2 by 2 by 2, and the answer would be the same as 16. And for the last method is simply known as the listing method. So again, we have the same problem, 32 and 48. So what we will do is we will all list down all the factor of each number. Now, if you have a problem dealing with finding the factors of a given number, meron akong tinatawag na video na kung saan pwede niyong panoorin kung paano ang pagkuha ng factors and multiples. Okay, let's just move on to the given problem. So we have 32. So what are the factors of 32? Okay, what we will do is simply dividing it by the first number. So we have 32 divided by 1, that is understood to be 32. What follows 1? So that is 2. So 32 divided by 2, that is simply 16. Then what's next? So that is 3. 32 divided by 3 cannot be. We cannot divide 32 by 3. That will yield with the exact answer. So what follows 3? So that is simply 4. So 32 divided by 4, so that understood to be 8. So therefore, these are the factors of 32. So when we check, 1 times 32, we have 32. 2 times 16, so that is 32. 4 times 8, that is 32. And for the last problem, so we have 48. So 48, so again, we always start with the first number, which is 1. So 48 divided by 1, that is equal to 48. What follows 1? Understood to be 2. So 48 divided by 2, so that is simply 24. Now what's next? So that is 3. 48 divided by 3, that is simply 16. Then what follows 3? So we have 4. 48 divided by 4, so that's equal to 12. What follows 4? That is 5, but we cannot divide 48 by 5. Then what is the next number after 5? So that is 6. So 48 divided by 6, that is simply 8. Then we stop. Meaning to say, these are the factors of 48. Then the next step, we will identify the common factor of the given two numbers, 32 and 48. So the common factors now are, we have 1, write 1 here, and we have the factor 2, write 2 here, and we have the number 4 here, so we have 4, so write 4 here, and we have the 8, so write the factor 8 here, and the last factor is simply 16. Then to find the greatest common factor, we will simply choose the number which has the largest value, and that number happens to be 16. So therefore, the GCF of 32 and 48 is simply 16. Now let us have a problem where three numbers are given, say 42, 54, and 72. How do we find the GCF of these three numbers? Again, we will solve that using three methods. Let's start with the Prime Factorization Method. So the first step is factor each number into primes. So we have the given number 42. Since 42 is an even number, let us divide it by the first prime number, which is 2. 42 divided by 2, so that is 21. 21 divided by 2 cannot be, so what follows prime number 2? That is prime number 3. So we divide 21 by prime number 3. So 21 divided by 3, so that is 7. Now, if we take a look at 237, 237 are prime numbers. So we stop. So encircle that numbers. Then, next step, we will list all the factors of 42. So for the 42, we have the factors 2, 3, 7. Then next number we have 54. So 54 is an even number, so we can divide it by prime number 2. So 54 divided by 2, so that is 27. 27 divided by 2 cannot be, so we divided by the next prime number, which is 3. 27 divided by 3, so that is equal to 9. Then 9 divided by 3, that is simply 3. So we have these prime numbers 2, 3, 3, 3, and then circle it, and then list all the factors of 54. So we have 54, 2 times 3 times 3 times 3, so we have this. And the last number given is 72. So 72 is an even number. We divide it again by prime number 2. So 72 divided by 2, so that is equal to 36. 36 again is an even number. So continue divide it by prime number 2. So 36 divided by 2, that is simply 18. Now 18 is an even number again, so we divide it again by 2. 18 divided by 2, so that is simply 9. 9 cannot be divided by 2, so we divide it by 3. So 9 divided by 3, so that is 3. 2, 2, 2, 3, 3 are prime numbers. So we will list down all the factors of 72. So that is simply 2, 2, 2, 3, 3. And then after that, we will find the GCF. So how do we find the GCF? We will circle the common factors that are shared by the given numbers. So we have the first factor shared by the given three numbers. So we have these 2. So copy the 2 here. And we have another second factor that's shared by the given 3 number. And it happens to be this 3, the prime number 3. So we'll multiply this by 3. So we have 2 factors. Now to find the GCF, just simply multiply these factors. 2 times 3, so that is equal to 6. So the GCF of 42 and 54 and 72 happens to be 6. Now let's try the second method in finding GCF using the same problem. Okay, so we have 42. We have the given number 42. So divide its number into primes. So divided by 2. So 42 divided by 2. So that is 21. 21 cannot be divided by 2. So what follows prime number 2? That is prime number 3. So we divide this by 3. So 21 divided by 3, that is 7. 7 can be divided by the prime number itself, which is 7. So 7 divided by 7, so that is 1. Now if the quotient happens to be 1, then stop. So the different prime numbers now are 2, 3, 7. And then for the number 54, so 54 can be divided by 2. So 54 by 2, so that is 27. 27 cannot be divided by 2. That can be divided by 3. So 27 by 3, so that is 9. 9 divided by 3, so that is simply 3. Then 3 can be divided by itself, that is 3. That is simply 1. Since 1 is the quotient here, therefore we stop. And the last number we have is 72. 72 is an even number, so 72 divided by 2, that is 36. 36 divided by 2, so that is simply 18. 18 divided by 2, that is equal to 9. 9 cannot be divided by 2 but can be divided by 3. So divided by 3, that is 3. 3 divided by 3 or by itself, that is understood to be 1. Since 1 is the quotient here in the last row, then we stop. Then how do we find the GCF? The GCF can be found by listing down all the factors, then encircle it. So we have the first factor that are shared by these three numbers, 42, 54, and 72. So we list down 2 here. Then the second factor is 3, 3, 3. So multiply the prime number 2 by 3. Then next, to find the GCF, we will multiply these 2 factors. So that is 2 times 3, understood to be 6. So again, the GCF of 42, 54, and 72 is simply 6. Now the next solution is we will combine 42, 54, and 72 in a single inverted division symbol. So 42, 54, 72 are numbers that can be divided by 2. So we divide by 2. So 42 divided by 2, that is simply 21. 54 divided by 2, so that is 27. 72 divided by 2, so understood to be 36. Next, 21, 27, 36 cannot be divided by 2. But if you are going to observe, 21, 27 can be divided by the next prime number, which is 3. So we'll divide this by 3. So 21 divided by 3, so that's 7. 27 divided by 3, so that is 9. 36 divided by 3, so that is simply 12. Now 7, 9, 12, we cannot find a number na pwedeng i-divide dito sa 7, 9, and 12. So we stop. So then therefore, the GCF now is simply the product of these 2 prime divisor. So that would be 2 times 3, so that is understood to be 6. And that is the same as the first solution here. Next, the last method we have is the listing method. So the same problem, 42, 54, 72. So the first step is we will list all the factor of each number. So we have 42. So how do we find the factors of 42? So we divide 42 by the first number, which is 1. 42 divided by 1, so that is 42. 42 divided by 2, so that is simply 21. 42 divided by 3, so that is 14. 42 divided by 4 cannot be. 42 divided by 5 cannot be. We cannot divide 42 by 5. 42 divided by 6, okay, that is understood to be 7. So therefore, 1, 2, 3, 6, 7, 14, 21, 42 are the factors of 42. Now for 54, so we have 54 divided by 1, so that is 54. 54 divided by 2, so that is equal to 27. 54 divided by 3, so that is simply 18. Now 54 divided by 4 cannot be. Same thing with the 5, but we can divide 54 by 6, and that is simply 9. So the factors of 54s are the following: 1, 2, 3, 6, 9, 18, 27, 54. And then the last we have is 72. So 72 divided by 1, that is simply 72. 72 divided by 2, so that is 36. 72 divided by 3, that is simply 24. 72 divided by 4, that is equal to 18. 72 divided by 5 cannot be. We cannot divide 5 wherein the answer is exact. Then what follows 5? That is simply 6. 72 divided by 6, so that is simply 72 divided by what follows 6, that is 7, cannot be. We cannot divide 72 by 7. So what follows 7? That is simply 8. 72 divided by 8, so that is 9. So these are the factors of 72. Then the next step is we will identify the common factors for the given set of numbers. So the common factors are, we have the 1 here, so we write 1 there. So we have the factor 2, so we write 2 here. And we have the factor 3, so we have 3 here. And then the last we have is the 6, so we have the 6 here. Now how do we find the highest common factor or the GCF of 42, 54, and 72? Now the GCF can be found by choosing the number which has the largest value. So the largest value is simply 6. Therefore, the GCF of these three numbers is simply 6.